Okay, how's everyone doing? You dried off a little bit? No one else sink or be underwater?
Hold on a second.
Last weekend?
So thank God.
What?
I was on the second floor, so hopefully.
Oh, good. Perfect. Anyone see the homework?
Yes.
You read it? Read it? Doesn't want to do it?
Yeah.
Yes or no? Did you get the money? I didn't update it, so it's missing potentially money. I'm just gonna take from whatever you have. Okay. You guys know how to play poker?
Oh, what? I thought it was blackjack.
I've played before, but I don't know.
So just because the homework is live and you know, it explains a few of the rules there, but I think the easiest way to think about how to approach it starts with just seeing it. So the game is fairly simple. You may have seen 5-card poker. So that is where you have a hand of 5 and you are able to get rid of cards and then pick up new cards in the hopes of making a better hand. The game that I put in your second homework is called Texas Hold'em, which is not like that. In that game, you only have 2 cards, which traditionally you are not showing to anyone, but because this is a homework problem, everyone will know everyone else's hand. Okay. Then there are cards that are played on the table for all to use. So there are initially 3 cards in the center. And then later on in subsequent rounds of betting, you get 2 more cards. So the game will look like this with 4 cards out. You have 2 cards and everyone else in the class has 2 cards. And you are trying to you're trying to calculate who has the highest chance of winning now and whether or not you have a chance of winning later on if another card comes out that you're looking for. Does that make sense? You may be tempted to use combinations here. Is that the right technique?
No, permutations would be better,
Why are permutations better?
because it doesn't matter the order in which you get the cards.
How many cards are you getting? Well, note, for example, you have 2 cards in your hand. How many free cards are there available?
So is the middle like the top of the deck, like,
What do you mean is the middle?
oh, the 5 cards in the middle, but those like.
So there are 4 revealed cards, like there are 4 revealed cards on the table,
Yeah.
and you only have 1 left to be dealt that is unknown.
What was the original question with combinations?
The original question is, how do we begin to think about calculating probabilities like this?
Just
Do we
whatever
use-
cards are left,
What's that?
just the total of whatever cards are left,
Okay, and how many cards can you draw?
2. Or just the one that you're
The
waiting.
one that's left. So combinations is not necessary here. If you, for example, didn't have any cards revealed, then you would need combinations because there's far more combinations than you can simply count. But the first time we're going to do an exercise like this, you're going to be using sample space analysis, right? You're going to think about event A would be if I got a diamond. Event B is if I get a joker, or sorry, a jack. Event C is if I get a 10, right? And then you have to see which of these combinations, right, of these probabilities will get you a win. You also need to know what everyone else's winning probability is. Because if an ace comes out and that's good for your hand, but it's better for your opponent, right? Then that's not a winning hand. Does that make sense? One of you has a really short stick. I'm sorry. I ran out of possible options. It's really hard to do a game for 7 players. Okay. Does that make sense? You want to know what the types of hands are, or you can look that up.
I think we can look, it's not canvas.
You can look it up. It's linked in Canvas. Yep.
Yeah.
It's linked in home. Okay. Without doing any of the calculations, do you want to bet?
So with blackjack, it's still the point to get 21, right?
This is not blackjack.
Technical.
This is technical.
So, okay, I have no experience, so I don't have anything based.
Okay. That's fair. Um. Well, then don't look at the rules now, because we're. Okay. This is the way that the board will be laid out, study.
And I'll bring them.
Okay, but we were having trouble thinking about how to draw 4 aces from 13. Is that correct, or did everyone get that afterwards? Did everyone get that after?
I think the thing that was confusing is because there was like an intersection, but technically the cards don't intersect. I think that's why we were saying like don't count. But you're calling the intersection itself,
Yeah,
one from each. I think that's what was confusing.
Okay.
I got that.
okay. Anyone else still struggling with that example? Good. All right. So we're kind of running out of the fun stuff, which would be the immediate applications. And we have to think, unfortunately, a little bit about the mathematics. Right? Yeah, yeah. Okay. You may have seen, we were talking about this thing called combinations. And we call combinations so we wrote it like this. We were said that it's N C for combinations, K. And we defined it as N factorial over N minus K factorial times K factorial. Now, what did this mean exactly?
For combinations, it's, out of like a total whole set, there's a little subset, K. And that is a number of which there are unique orders that you can like arrange those.
Okay. Where in that subset, we don't care about the order. So N is the set. K is the subset. Regardless of ordering. That's really important. Okay. You may also see it written this way, and you'll hear some people say the words. And choose. Okay. You ever read that before? Okay. So that just so happens to be the binomial coefficient. Right? This is our definition. My spelling is absolutely mongo bad today. It's the definition of what we call the binomial coefficient. All right. And we use that in particular when we think about A plus B power n. That is written as a sum. Right? You write this as a sum with n up here and k to 0 to n of n choose k, a k, b, and minus k. That's right, Chris Money. Okay, so let's do some examples, right? What's the most common example you'll see of the binomial expansion?
Mathematics example, I was just gonna say like 1 plus x Is our other number.
1 plus x. What's the first expansion you ever learned? There we go. Okay, good. And what's that?
Plus X.
Very good. You just memorized that, right? No, you actually did it in your head? Okay. Well, I use that. No, just kidding. But let's see if we can. Right? Let's see if this is still valid. So here A would be 1. B is X. A is K. And N is? Let's see if we can write this out. So this is a sum. Oh, it's good. I see a sum here. Let's look at these binomial terms here. So for k equals 0, what do I guess? This n would be 2. 2c0. A is what? 1 to the 0. And then B is X. And minus K is 2. What's this one? You tell me. 0 factorial is 1. N minus K is 2 minus 0 is 2. And 2 over 2, 1. Good. Okay. Oh, that's interesting. That's already one of the terms. Right? Amazing. So good at your job, Chris. All right, what's the next one?
Half of ones.
Okay. So where?
So 2C1.
You see 1, good.
Then 1 to the 1,
1 to the 1.
then X to the.
Okay. And what's 1 to the 1?
Oh, 1.
Okay, that's really easy. That's 1. What's this one? 2. Yeah, very good. Amazing. All right. You see a pattern yet?
Yeah.
And it's a sum, right? So what's the third one? You think it's x squared?
Oh, the final answer.
No,
Look at it carefully.
It's gonna be 1.
It's gonna be 1. But let's see how it is 1, right? So the first term actually was the x squared term.
Oh, I see.
Yeah, everything else in front of it was 1. So let's do this one. What's 2c2? It has to be 1.
yeah,
So let's look at it, right? This is 2,
Oh,
and this is 2. And this is 0. 0 factorial is 1, 2 over 2 is 1. Okay, so this is also 1. Next one?
1 squared,
Okay, 1 squared is
1,
good.
and then we have X. And 2 minus X is 0.
X to the 0. X to the 0 is not x.
1.
Ah. Amazing. Right? Okay, so these are the binomial coefficients. And what I mean by that is this idea of n choose k is going to show you how many unique subsets there are inside of a larger set of n. This happens to be very helpful, especially when you consider things like multinomial coefficients. So we could, for example, take something like this, which is binomial 2, and you could expand it. And you could ask the question, what about x1 plus x2 plus x m. Some larger sum to the n. And it just so happens that you would have a larger sum like this. And you have the factorial counting up here. Okay, 1, 2, 3, so on and so forth, all the way down to nm, all times. Oh gosh. And maybe that doesn't seem very useful right now, but this is sort of a standard thing to have in the back pocket for when you need to do expansions of multi-terms like that. Because sometimes it's not so obvious, right? And if you can do something similar to what we saw, say, in E and M or in fluids, where you can identify a dominant term, you can do an expansion like this. You break apart the term and say, well, anything of x squared, I'm going to throw away. I'm going to look at the first and the second order terms. That's a very standard mathematical technique when you're considering the relative weights of the power of something, right? Something goes like x squared and it's small, then you throw it away. Whereas something goes like x squared and it's large, then it's the most important term. Okay. Questions, comments, concerns? Let's do one more example. Okay. And this is perfect because there's 4 of you. All right. This is a well shuffled deck. I'm just double checking. Okay. Well shuffled deck. You have money. I'm going to deal you all 13 cards. 13 cards. Uh-oh. Well, John doesn't get to play. Maybe John can bet on whoever he wants.
Sure.
So I'm going to deal you 13 cards. And the question is, what is the probability that each one of you has an ace? Uh-oh.
Like, do we all have to have an ace?
You'll have to have exactly one ace. You have 13 cards.
So that means if one person has 2 aces, then you're all.
Well, no, depending on how you want to bet.
Oh, so we came back from the like that, not the person on the race.
Yeah, you can either bet for or against this one.
I'm gonna bet $20 that someone, that all of us are not gonna have a single ace, or like.
Well, hold on. Let me make it clear. There are 52 cards. Hold on, just wait.
Divided by 4.
52 cards. All the cards will be dealt.
I know,
All of them.
I misworded it, and just like, oh, like, basically, like, against that each one of us are gonna have an ace, that's what.
So you're betting against the probability that you're thinking that one person is going to get 2 aces at a minimum.
Yes,
Maybe someone gets 4.
Not 4, but you know, it's not.
Well, you have to tell me, think about this right now, and I'm willing that you can have maybe 3 or 4 minutes to write down what you think the probability would be, right? Because you're getting 13 cards.
Yeah.
All of the cards will be spent. There's no hidden aces anymore. Right? And don't go looking it up.
I'm not.
Is there a 30?
There's all these probabilities, they all exist online somewhere.
Ah, okay.
Because cards are
That
money.
makes sense.
Okay. So take 2 or 3 minutes. Think about where and how you would solve this type of problem. Now, are you using just simple event A, B, C here? No, right? You're using something more complicated because you have so many cards, right? So what are you planning to use here? Combinations. Oh, interesting. The thing that we're talking about. Okay, so let's try it.
That's-
Might also be helpful here to look at this relationship. We call this N. This would be the total number of ways that any full set could be split up into smaller subsets. No? No idea?
think I
Okay,
got
let's
it.
talk about it. Let's talk about it. How do we do this?
I first looked at like the sample space, or a combination from the sample space, and I got like 52C13. It's like,
If you do C13 means what?
so out of 52 cards,
Mhm.
these are the number of ways like 13 cards can be arranged.
Good. So this is the number of ways 13 cards can be arranged. Good. So that considers a singular. What do you mean times 4?
No, no.
Okay, well,
So hold on a second. So what we want to think about is something like this is choosing from a subset. But what if I use the whole set into some fraction of portions?
I'm not sure how to use that with the N on top of 52 and then on the bottom. Is it 413s?
Yeah. That's exactly right.
Oh.
So the n is the total number of objects. Depending on how you cut it up, m is the whole number of sets. Now this can change, right? This can have different weights. So n1 might be, okay, I need 4 aces, right? And so therefore there's 4 in this set, right? But then I need 4 queens, 4 kings, whatever, if you wanted to split it up in a different way. But let's think about the top one for a second. What did you say the top was? 52. Is 52 factorial a small number?
no,
Okay, so please someone with a calculator, tell me what 52 factorial is. No, sorry, not a real calculator. I don't break your real calculators. Try
Eight
oh,
times 10 to the 67.
say that again.
8 times 10 to the 67th power.
8 e 67. Do you know any numbers this big?
What's EB?
Oh.
6.
Oh, sorry.
Sorry,
Sorry.
let me fix it. I'll fix it.
so what you're saying is that the numerator is so big that we don't have to care about the denominator.
I never said that.
That's what I'm.
I never said that. Don't imply things yet. Let's finish individual pieces of thought first. So let's first fixate on this number, because that's an absurd number. So every time that we deal the cards is a brand new combination that no one has ever seen. That's my first posit, okay? And you can show this for yourself. If you imagine there's roughly 100 billion people who've ever lived, every time that they shuffle, you're never ever gonna get to that. And yet, I think most people would say that I shuffled those cards, right? Uniquely. And yet, we have these like built-in things where if I open this deck, that is a uniquely shuffled deck, right? Even if I just move one card and I put it somewhere else, probably no one has ever had that combination of cards before, right? Okay, so we have to think a little carefully here. So this is a huge number, but now what's 13 factorial?
A little smaller.
It's smaller, that's true, but not that much smaller.
6.2 times 10 to the 9.
6 times 10 to the
9.
9. Good. And what is the process that we're doing here on the bottom? Is it times 4?
To the power of 4.
To the power of 4. So how does that interact with that one?
Six.
Makes it bigger, right?
Do we apply the power of 4 after we take the factorial? Or every single time we go down? Order of operation, I can talk. After, that's okay.
It's funny, there isn't a PEDMAS for an exclamation point.
1.5 times 10 to the 39.
What's that? Say it again?
1.5 times 10 to the 39.
39?
Mhm.
So that's also a Gargantuan number.
Yeah.
Right? Okay. So this is, what is that again? N?
How many ways n objects can be divided into n piles?
Right, what did it mean to you? I can read. I wrote it. So I don't need to hear my own voice.
Yeah.
I wanna hear what you actually understand.
Isn't it just the combinations? Of
It's a combination of,
13 different card, 13.
so what's the major difference between this and that?
I don't
The
know.
combination is just taking a single set into account. While
Let's be careful with our words. You're almost exactly there. Just changing one word. Subset. Very good. Okay, keep going.
combination of a single subset versus how an entire set can be subdivided.
Subdivided into M piles, and they can vary. Right? Okay. Good, ready? Okay. So this is the total number of ways that N objects can be divided into M piles, and it's a lot of ways. Lot of ways. Good.
Then how do we know how many ways it could be right?
So remember that when we think about probabilities, right? Go back to this definition. What's the top?
And then a,
Or just what you want over it?
Yeah, for example.
Okay, so which one of these did you just calculate?
And it's,
Very good. So this is our NS, right? We're gonna call it capital N right? I'm not gonna show you NA yet. We'll do it after we do the betting. Well, because then you know whether or not to bet here. But let's think about our intuition.
Sarah asked if she could
Uh,
text.
Sarah, you can bet, but we're gonna bet in a funny way. Okay, so there are 4 piles. Okay? And initially, you have no information about the distribution of aces. Okay, so at first, I will ask you whether you want to bet on whether there is or is not an ace in each one of these 4 piles. And then I'll reveal a card for all 4.
Just one,
Just one for each. Okay, but you know, all 4 at one, right? And then you'll see if you want to bet again.
if all 4 aces.
Okay, so remember, if you bet that there aren't at the very beginning, and there are, you will lose that bet. Right? Okay, so let's do it. We're having fun, right?
so much fun.
Can't cheat.
What?
Wait, can we reword that one more time for the combination thing? So the combination is that one there is a subset calculated in space,
Subset of the entire set.
subset of the entire.
This is
space.
using the whole set in M piles or portions, but the ends are still the same, N objects. And
Did
is
you
the whole
rig
set.
it?
What?
Did you cheat or rig it, or is it okay?
What do you mean cheat or rig it? What are you talking about? I would never be caught so red-handed except for the first day of class. Right? That was a learning example. I shuffled in front of you. I'm not a magician. As
Yeah.
much as I wanted to be as a middle schooler.
So,
Okay. Now let's record some bets. So the first bet that we're asking. 4 aces. Split. Evenly. Mom?
I'm gonna say no,
No, and how much are you putting on that?
20.
20. Trinity?
I'm gonna say no. I don't want to 5.
John?
I'll put $3.
And what? No.
Yeah,
I'm gonna take you no for $3.
That's fun and go all in.
it's very
Hold
low.
on, read, see.
Read it down. Come on, bro.
You want to do a split bet, yes, no, but then half this, half that.
All right, read.
I'll go with yes.
Wow.
Yes,
For
$500.
$10.
10 doll hairs. Okay,
So you're saying
I'll
you're
put
paying
yes.
$10?
Go.
and Sarah?
Sarah, turn the mic on.
Mike, check.
I want I want to say no for $30.
For $30, big spender! All right, so more than we time.
Why do you put?
It's gonna be really good to solve for.
Yeah.
For
that's
sure.
all it's really- and then
I'd be pretty
don't get
upset.
small.
Here we go. So close to graduating, like, that's it, search up with it. Okay. All right, so, for folks who are online, there's 4 piles on the desk. And I'm gonna reveal the top cards. There's an ace in the first pile,
That sucks.
there's an ace in the second pile. That sucks. Wait, why does that suck?
That sucks. Wait.
Oh, man.
That doesn't mean anything yet, right? Or does it?
I don't know.
Fence.
Yeah,
We don't know about the rest.
We don't know about the two of them.
I'm so
So
upset.
no, so now does anyone wanna bet?
More?
Yeah, more or less. Now you've seen there are 2 aces.
No.
I'm trying to
So you're staying,
think with my brain.
Oh, man.
Brain.
Think with your brain, not your emotions.
They're all 4, I swear.
Yeah, I'd be very
I
disappointed.
know.
I'm bored then.
Very
It's not
disappointed.
spoon playing. Here.
If it gets to be 30, then I'll just. bet
Wait, how many
20
rounds are you gonna do this? Like, are you just gonna do?
I think
one
reveal
more?
all of them, right?
well, we'll do it until either everyone's busted. Right? Like, if these 2 are right, then all of these are wrong. Right? And then there's no possible other combinations.
Okay.
Yeah.
It's gonna be yes, I'll spend 20 for yes and I'll.
Yeah, it's all right up. Well, that's a very interesting proposition.
Let's go.
I'll wait one more round and then.
Anyone else wanna bet?
I'm okay.
I'm sticking.
You wanna re-up? All right, so from the leftmost, which doesn't have an ace, a 10. The second one, which doesn't have an ace, a king.
Okay.
The third most, which has an ace, a king. The fourth most, which has an ace, a 3.
Oh, my God.
Chris Money, I want to bet $10 more.
$10 more on what?
No.
On no! Damn, okay, let's
Oh,
go.
no. There's like no guarantee anymore. No.
7, 2,
Let there be an ace.
9,
Just put us out of our misery.
king. Oh my god. This is so spicy.
Wow.
Keep going.
Keep going. Anyone else want more?
No.
Wait. Yeah, put mine at 20.
20?
Damn.
Girl.
What was the
Oh.
attitude before when it started?
I'll add 12 more to mine.
Mine's 12.
You're fucking-
Eight,
I was about to say. Okay.
queen,
Let these- No,
Queen.
okay. You
Jack.
just need 1 ace, right?
Yeah, I
It's
need what ace?
Just they want 1 ace in these piles, and you want 1 ace in either of these piles. Ooh, that's true.
I'm still sticking though.
Should I wanna go.
Chris Money, add 10 more.
What's
10
that?
more?
Hold on,
10 more. 10 more.
10 more?
Also,
Sarah,
put
you
10 more
have
for me, 10 more.
Chris Money, all in. I'm kidding.
I'll go 10 more.
Oh my god, you have no evidence to show that that was a good move.
You also go.
Okay, ready?
I'm not.
Good.
Ready?
Oh my god.
We're starting over here.
Okay.
On the no ace pile, 9.
Okay.
No ace pile, Jack.
Let it be easy, let it be easy. Oh my god.
8.
This is a big one, girl.
Sorry that it isn't as quick as a TikTok, but I'm trying to get you down. Think between the options. You have seen a lot of cards now. So you have now seen 5 cards of the 13.
We have 8 more.
8 more times to bet. Oh,
Does that change anyone's mind?
I'm gonna stay where I am.
I'm sticking.
I
I'm
need the
sticking.
ace.
Ready?
We're just-
Is this an ace?
No.
No.
I really hope not.
Oh.
Oh my goodness.
4,
That looked like an ace.
3, no, 5. Jack.
Oh my God.
It was wild that both of the aces were right on top.
Yeah.
That was not expected.
Black, black, black.
Oh my god.
7. 2,
Okay, alright.
6.
It just has to be one. It just has to be, oh my.
The other two.
Yeah.
They might be somewhere, right?
They have to be so
Yeah.
Are they in that pile over there? Or you just? Okay, alright, jokers.
Ready?
Yeah.
Start on the right.
Yeah.
Yeah.
Start from the
You think
right.
that's gonna matter?
That's gonna matter. That's where the
That
ace
matters,
is.
It
yeah.
doesn't matter, but just.
Oh my goodness.
Ace.
Oh.
No way!
Okay, so now we have 3
Oh.
piles with an A in it.
Stop.
Where are you putting the 20?
One, yes.
Yes. So minus 20.
Minus 20? Yeah.
At 50.
Oh, so you don't.
So you're adding 50,
Yeah.
Rolando.
Yeah, let's go.
I'll add 53.
So,
You're at-
Oh my god. You know what? I'll add 50. Let's do it that way. I'm gonna say that it's not in that pile. I'm gonna say it's not in that pile.
Trinity, you good?
There's no way. There's no way.
Sarah, do you have any thoughts?
It's so
Nope. No thoughts.
low. It's so low.
Oh my God.
Where do you want to start now?
Yeah, I don't care.
Let it be an ace. Oh my god. That's fine. There's more cards.
7.
It just needs to be one.
Four.
3.
I thought I lost a lot of money right there. I really did.
Are you so scared, John?
I'm very nervous. I'm genuinely nervous. Yeah.
All right, keep going.
Keep going. Do it. Just one ace. In the wrong spot.
3. 10.
What is happening?
10.
What is happening?
It's just cards, dude.
9.
Keep going, keep going.
What is happening right now? The likelihood of that happening is just so low, I feel.
How low is it?
Very.
How low?
One out
I
of.
don't know what etiquette.
Like, that's like, I would have to assume it's like on like either like the lower end of like the likelihood of like a bell curve. It's just not,
So
Probable.
so think about the reason that we're doing this at all. Why do we do this exercise? Is because in our lives, we will hear about 50-50 probabilities and a 30% chance of rain and these other numbers. I gave you 2 numbers that seemed utterly intractable. 10 to the 67 and 10 to the 35, and that ratio was your bottom end. And yet, somewhere in your heart of hearts, 2 of you believed well enough that aces could have been distributed equally when the whole thing was spread out. So there's a disconnect here in the way that we think about our numbers. Is this a 50-50 chance? Is it a 0% chance? Is it a 12% chance? And I know you don't know, but there has to be part of your intuition that I'm asking you to tap into. That's why we're using money. It's not arbitrary for fun.
I would say
Right.
less than 10%. I would
Okay,
say,
less than 10% means that you would want to get at least 10 times return on your money in order for it to feel like a good bet. So you in fact wouldn't bet, which is what you said.
yeah,
So then are you still sticking by that intuition? Because you should say, well, I could bet $100 here. I could bet $100 here. And I would, if I did this 10 times, I would break even. Or I would, no, sorry, if I did this 10 times, right, I would make $900
right, like the light.
if you bet 100 each time. Because you only lose once if you think it's a 10% chance. But if you think it's higher, right, that's where it gets risky. So we all agreed at the very beginning that the chance of getting 4 A's in one pocket, very unlikely.
Yeah,
But how much more unlikely was that than what's happening now? Because this is blowing everyone's mind.
yeah.
And it seems like is that the most obvious outcome or not?
It might be a little probable, we just didn't.
They have to get spread, right?
Yeah.
So they do have to get spread somehow. So is this the most obvious outcome, or is this less obvious than getting 4?
I don't know anymore.
Nobody. Say that again, say that again.
It would make most sense to one of them had 2 or something.
Yeah, at least one.
Yeah,
Like,
it's doubled up.
Like something like 2011 seems
Yeah.
plausible, or like two.
Well, what do you mean plausible? What do we mean by that word plausible?
It just seems like there's a, like, for everything to have 1 is like one way, but then you can have different ways for it to have 2, so then it's.
Yeah. Or
Ah,
combinations of, like,
interesting.
2, 1,
Okay, so now we're thinking back to the reason why we do the math at all, which is the number of different ways to make this. So when we do the NA top. Okay, compare the two. Okay. You ready? You wanna bet more or not?
Wait,
I'm gonna
Okay.
stay where I am.
I
wait.
feel like one of them has to have 2, but I don't wanna lose money. I wanna be rich.
I wanna be rich, wanna drive the toast.
I wanna have fun. I wanna go all in minus $1.
Oh my god.
Oh, the buy.
So you're resetting your
Wait,
money.
all in minus $5. I'll keep
Minus
my
$5.
Crazy.
all in minus.
You want me to join you there?
I don't know.
There's no way. I don't know. There's like a weird, there's a weird situation that it could just be said. You guys are going all in? Just do it, yeah. Yeah, you guys should, yeah. Look at the likelihood, right?
No.
You have 3 cards remaining.
No, dude. That's not gonna happen.
All right, anyone else wanna bet? Trinity has put her whole life on the line.
Wait, don't be
I'll do it.
scared.
Wow. Reed, you're going all in?
Except for $5.
Oh
Wow.
my
Why
god.
not?
I am
Yeah, is it was already went in?
I'll remember me when you made it, bro.
just remember me when you made it.
We have like 2 or 3 more weeks of gambling, right?
Really happy?
Yeah.
Money was gonna be sad.
I'm gonna wait.
Funny.
You ready?
No.
Which side do you wanna go from?
I don't know, pick that one, that'd be so way more disappointing.
Imagine this.
No, dude. Oh, god.
The anti
I will actually throw.
Oh my god.
Bro, this is making me sick.
Okay, so now knowing what you know, there is a total of 8 cards. The odds that the 2 aces are in this is what?
No,
One out of 8.
there-
What?
It's higher now.
there's
It's
only one
higher.
ace left,
There's only 1 ace. You have
Yeah.
2 cards here,
so it's like, what, like?
so it's 25%. Pretty good.
That's pretty good.
Two out of like the 8 that's remaining, yeah.
Well, this is brand new and right, you can't, this isn't the original public. This is what happens when we're down to 2 cards. More money or not?
So we cannot change. We cannot change.
There's a higher.
Well, not if you're all in.
Yeah, obviously. But,
Oh, I'm not.
Well,
But you're absolutely welcome, but you would have to bet minus now.
I'll still be less than that. You want-
Well, if you decided, so see what is it with it, as soon as she saw the 3rd ace, she bet also on yes. And so either way, if she wins, it cancels out.
I'm sticking,
Should I go?
sticking, because it'd be funny. I think it would be. funny.
No. Oh my god.
Yeah.
Read which side you want.
I don't care.
Trinity?
I'm
I
gonna
think
throw
you
up, yeah,
care.
go ahead.
This one?
Yeah.
No,
Huh?
I'm just gonna say no. Oh my god.
Oh my.
Alright, that's it.
No way. Stop it. Ace.
Just do it right now.
It's just gonna end up you forgot the ace somewhere.
Just flip.
Yeah, you left the ace at home. Yeah! No way.
No. Give me my fucking money.
Okay, here's what we're gonna do.
5-1.
Hold on to your money right now. Hold on to your money. So here's what we're gonna do.
Wow.
I'm gonna take a.
Why was it
vote.
the last? Why was it the last card?
Probable.
Why was it the last card?
That was crazy, right? So welcome to betting. Okay, so hold on to all your money right now because I didn't add in the stuff that we did online.
So whatever your totals are, they're gonna be slightly adjusted, and then you're gonna either win or lose a lot of money. I'm sorry, Trinity.
I have $10 actually, because I made 5 months.
Oh, there you go. That was
So
sick.
here's the way to think about the probabilities. We just calculated a very big number.
That's net.
Good job, Reed.
Good job.
Good job.
That's the question.
Well, you answered.
We still need to do a calculation, right? It's not an encyclopedia. I need you to be able to know how to do it.
Right.
Because what if you get a homework next week that has you figure out something else similar?
You
Yeah,
should.
but I honestly don't, look.
What do you mean? Well, yeah, we want to do two things. We want to build our intuition while attaching it to physical events. That felt crazy.
Yeah.
Was it crazy? Okay, alright. So let's think about the total number of bridge dealings. We said N for dealing the whole pile out equally was 52 factorial over 13 factorial to the power 4, right?
Yes.
What are the total number of ways in which the 4 aces can be distributed with 1 in each hand?
Isn't there only one way?
Because order doesn't matter, right?
I mean, all the
Oh,
other
wait.
cards.
Order doesn't matter, that's true. So now we're thinking about what?
Is it 1 for 13 or?
You have 4 cards. Aces. Right? They can be distributed.
I'm saying combination. See,
Yeah, would it be like one out of, or 12C1, where you want one of them to be in that pile?
It's kind of similar to what we did on Monday. Remember, we're using a whole pile. So we're using a whole pile of aces. And that is,
that's it.
Oh, so
4
4 out
total
of
aces. And how are they distributed?
around 13, 4 piles.
1 in one pile, 1 in the other pile, 1 in the other pile, 1 in the other pile.
I hate it.
That's a small number.
That's correct, but we're not done yet. Okay, this is 1 ace in each hand. Good, and what about the other parts of the hand? Is there any other part of the hand?
The rest of it.
Oh, interesting, so there's lots of other parts of the hand. So how do I think about the other part of the hand?
As a combination, because you can't, you know,
It's just the same.
Just random, the rest of it,
What do you mean random?
like, it's not gonna be in order, so we should think combination, right?
I was saying.
So when we are saying combinations, we remember, we want to think not, that doesn't just mean C means choosing a subset. Okay, I am treating 2 distinct piles as their own quantities. The aces are their own set. We used the whole ace set. So we used N. Okay, what else is in the hand?
The rest of the ones are.
The rest of them. Now, what does that look like?
48 factorial.
There we go, 48 factorial to save us. And on the bottom? Yes, correct. 12 factorial, 12 factorial, 12 factorial, 12 factorial. Okay, interesting. So now the numerator is not this teeny weeny number, right? Because this thing is sizable. Does that make sense? So what is it? Let's do the whole thing. So the probability N of 1 ace per looks like write it out. It's gonna suck. All right, 4 factorial, 48 factorial, 13 factorial to the power 4 over 12 factorial to the power 4 over 52 factorial is about 10%.
Wow, oh, cool.
So we got lucky.
They got very lucky.
They got very lucky.
All skill.
And remember when you said it was about 10%?
Yeah.
spot on,
Thanks.
right?
But also, that's how confident I was that it was gonna happen, and then it happened.
Okay,
So that's.
so let's try the other one. Two aces. Two ace in one hand. 0, 1, 1.
You said for. That's what be two? Oh,
Yeah,
aces
two
in one
aces.
hand, okay.
So. Only having two. Yeah, that was very.
The fact that it was very end too. Okay, go ahead.
Very.
I got lost all my money for something that's 10%.
Yeah, oh, God.
Hey man, let's look sometime.
Life sucks. Just don't bet.
Yeah, exactly.
I mean, the fact that Reed didn't lose all his money,
That is
right?
Yeah, probably.
Incorrect.
Rigged.
Incorrect, not when we start actually playing.
Yeah.
Okay, so, when there's two aces in one hand, you need to make it do NA.
Yeah.
You need to do that.
Is it still the 4 and 48 on top with different stuff on the bottom?
Why would that be? I mean, that's right, but why would that be? Let's just go through the mental process so everyone understands it.
Is there still 4 aces and 48 on the cards?
Good, so we treat this as one subset. And we treat this as another subset, right, of which we're using the entire.
Then would it be that?
Would it be?
So, okay, so for this one, what I'm thinking is that it's gonna be 4 factorial over like 2 factorial times 0 factorial times 1 factorial times 1 factorial.
So 2, 0, 1, 1.
Yeah.
And notice that these would all be the same, because 0 factorial is the same as 1 factorial.
Yeah.
This one is 2 factorial, now it matters, because this number got
Yeah.
smaller. You're like, well, oh, that's obvious, Mateo. Well, what about this?
Tremendously.
No, they wouldn't be.
10, 12,
13,
11, 11.
13,
Okay.
because he has an extra card, because he got a 0.
Uh,
12, 12, and 11. So does this number get bigger? That's money. All right, let's look. So this number became 2.
Two, or 4 factorial, and then,
What's 4 factorial?
Two factorial, so it's
4.
4 times 12, it's just 12.
Oh, 24.
12.
12.
Okay. Oh, 12. Oh, after you reduce, is that right?
Yeah.
4
Okay.
times 3,
Yeah,
12,
times
times
2.
2, divided by 2.
Divide by 2.
Oh, divide by 2, yeah.
Gotcha.
So that's 12.
Gotcha.
And on the top here, what do we have?
Still looks 48 and
Good, the 48 is still here, like that comes from that. What happens here? Do we care about that? It's already included, right? And what's on the bottom?
wait, why did you do 13?
The 13's in the
13 from here. So sorry.
Yeah.
13 is not gonna, is the 13 affected?
I don't.
I don't think so. That's just the set. Yeah.
Wait, I'm confused. What is that?
Oh, because it can't.
That's from.
So it's 13 to the 3.
Well, just wait a second. Let's write it out for everyone who's
Okay.
following at home. Okay, so what does this become?
11
Uh,
factorial, 13 factorial. And 12 and 12.
Again.
Hey, what's that?
Having so much fun, winning all this money, not.
Uh, 4 point, I don't think that's right.
4 points, no, it's gotta be less than 1, right?
Yeah.
400%.
4 times. Yeah.
My parentheses wrong. 11, 12, 12. I just did this for this. Not this one.
Yeah. Wait, you're over, so-
Hey, yeah, that's what I know.
0.0,
Yeah.
not 4 point. You
I
said
was
4.
gonna, I was gonna do 4.8%.
Oh,
Ah.
I heard the word 4, and I was like, can't be, or the 1.
What's
400%.
the other 90%? What's so likely?
That it's gonna be like random as hell, it's just, I don't know.
Well, like, where's the ace gonna go?
Oh, is this
That's
just,
so
this is
likely.
just though for the order? Are you considering order? No, you're not. This is.
I mean, I guess if we really
I-
wanted to, you
I'll
could
accept
set,
100.
you could set the right side equal to like 90. And then the thing that's changing is like. I guess what we don't know.
Okay, hold on, so we wanna draw a really important distinction here. If I deal out all the cards, what is the probability that all 4 aces get dealt?
100%.
100%. Is that the same as summing all 4 of the potential options?
Well, the ace never
No.
goes
I
somewhere.
think so.
Right, but it's not the same as the aces simply just going out of the deck.
Right, like we're not keeping track of the piles. We're
So-
just seeing this stuff.
So for example, let's say, I wanna calculate the probability that this is 1 ace per hand, right? So this,
All the different ways you can put the aces down should add to 100.
why is that expected?
Because you're
That's how we
doing,
normalize stuff.
Like if the N is for all the cards, not just the aces.
Right. And keep in mind, when you're dealing out all the cards, there's a number of different ways you can do it, right? So if I have 4 players that are sitting with me, right? This one here, where is it? 2 ace in one hand, 0 0 0 1 1 in others. This is not saying who has what. So now I have to count all of the times that this can happen distinguishably. And this can happen distinguishably. And one person can get 4 aces distinguishably, right? And then I can add up all of the individual ones. So it's not only this is an event, like an event A, but all of the potential events of dealing the cards out, right? So if we had us 4. This one here says 2 ace in one hand. I didn't specify whose. Right? So I want to count all the possible options. I have to multiply this by the chances that this person gets 2 aces, the chances that this person gets 2 aces, right? And then you gain some of the numbers back. But the individual probabilities are low.
oh, we haven't done like 3 aces either, huh?
Right,
Okay,
you think that's gonna be better or worse?
I think, well, no, we can actually kind of.
Well, you can see the route here, right?
No, but then it'd be 4 factorial over 3 factorial. That's,
Just
6, so
4.
like 24 divided by 2.
That is not the dominating factor here.
So that was.
I'll just, no, I'll just, like, little, like, 4.
These
Oh, yeah,
these are the dominating numbers, right? Right. Say
Okay,
30.
that again?
So it is most likely for what one. So it's not.
but it's a shitty likelihood,
Yeah.
right?
It's like, it's still bad, but it's the best.
Yeah, isn't that wild though?
Is the best for the four aces,
What's that now?
it's the best when you're considering like all, like where the fours would go.
Yeah, because it's gonna keep getting smaller when the numbers at the bottom get bigger.
Yeah, so notice that if we go down to 4% here, like you said.
Yeah.
Right, that's half as good, it's just knowing they're gonna be delta equal.
Yeah, but it's half as good, but you multiply by four, because there's four piles,
Right, well,
right? Cause you said we didn't consider if the two aces are on this person, or this person.
no, so yeah, so this is the probability of that happening. Right, just that.
Oh, in total?
But to say, if we add all the probabilities, we've added all the potential outcomes. Her argument was, if I add this to this, and then I add two smaller numbers, I'll never get to one. Which is
Okay.
all potential outcomes. And I'm saying that is not what we're looking at here. We're looking at all the potential outcomes times all the ways we can do
Yeah,
Right?
okay.
it. And I didn't say, what's the probability of, right, we could ask whether this one is more common than this one. There's only one way to make this. There's 4 ways to make this. You're absolutely right. Right? But it's not the more common. Make sense? Okay, so yeah, statistics will be a little weird, and this is why we're trying to, again, as fun as this is to do this betting, you really want to search deep inside yourself, because these numbers, they're gonna feel foreign, they're gonna feel like they're disconnected from reality, and they have deep, meaningful connections. How do we make judgments based on a 10% probability? Well, I would have told you not to fucking bet there. But if you have someone who bets yes and someone who bets no, guess what? You're always gonna have someone be right.
Yeah.
Right? Because one outcome will occur. So do you want to do it again?
I'm good.
When you do
With the
three-
same game?
Yeah, the same game.
Oh, God.
No. you
I don't know, yeah, like at this point, I feel like that was like a very rare
So here,
scenario.
yeah, here's the way we'll do it,
It
right?
would be no, for sure.
I'll just reveal one pile of 13.
Okay.
Right?
Okay.
Wait,
Oh, I see.
If you
So
do
I'm-
3 aces, it's-
I'm not gonna do this again. I'm just gonna ask, do you want to bet again now that you know what the probabilities are?
no,
Oh, they're all trash.
That's right.
They're all low. No, I did the 3 and it's.
It
point
should be
zero
no,
one.
it should be no every time. I feel like, since the likelihood is low. Oh, man.
Stop it.
Stop it, stop.
So this
it.
is actually,
you can.
I'm hinting to something that we're about to do, okay? We're gonna get into the more mathematical concepts on Monday. And what we're doing is we're repeating an experiment, okay? So mathematically, you have calculated something. You calculated the likelihood that we're gonna get an ace in every single one of these piles. I'm giving you the opportunity to run the experiment again, knowing your pre-calculated value is that if you say take no here, you have a 90% chance of being correct. That's the argument, yeah.
But you said like you're gonna reveal just one of the stacks though, so how does that like take you?
Well, if I see an ace in there, then we'll move to the next one.
Oh, you should reveal a stack at a time.
Oh, you go stacking time instead of just.
Yeah, we're not gonna go through this
Just
process
fan it,
of thinking about the numbers as we go.
Okay.
I just want you to see.
Okay.
No, you have to bet pre any information, because I want to think just about this probability.
I'll put 100 down so that I can try to make up what I lost. No, 100.
Okay, so
Yeah.
John,
Under 100.
Yeah. Oh, yeah, actually, that depends if I have
Already
100.
did.
Hang on. I don't have 100. Hang on. That would be like,
Jam change.
I'll
like
do-
50 cents.
well,
I think I know I have
if
like,
you bust, I'll just do the different.
okay. Then I'll do like 20, since I
Okay.
can't bet all the way.
In the second round. Let me delete these all.
Yeah,
Sorry,
I think the last time. Oh, what was it? What was my name?
All right, anyone want to go?
I'll bet 50 on no that they aren't even.
I want to bet 50 on no as well.
Like.
Sarah wants to know?
It should be no, guys. It should be no.
Yeah, the chances of actually.
Yeah, that would be
Did I
disgusting.
bet like $5? Oh, no.
Yeah.
You're only 5?
Dude, okay, do 4.
John, did you say you wanted to?
Yeah, I will do 20. I know I have at least 20.
On no?
Yeah, 20 on.
Why'd you read that for me?
Oh,
Oh, sorry. I'm not good at seeing things.
It's okay.
Okay,
I'll do 100 for now.
cash money on yes or no?
No.
Oh, well, yeah,
You're
now
not gonna
it's-
double up on the money that you won?
Yeah,
This dude.
that's pretty good.
20 for yes.
Whoa, okay.
God.
I would be really bullish.
God.
Alright, ready?
If it happens again, that'd be insane. Just,
That'd be
yeah,
insane.
You're gonna get instantly disproven.
I hope it's like 3 aces or something.
1 ace.
Okay,
Oh my god.
it's starting. This is-
Starting, starting again. 2 aces.
No.
Oh.
2 aces.
Oh, good.
No, there's a second ace right here.
Oh, yeah.
Oh.
Say that.
You got
I thought
it.
you said 2 aces and 1. Oh my
Nope.
god.
She said she wanted to bet on
No.
third pile. Just
Just
third
one.
pile it.
Oh my god. Oh
What's
my
the most
God.
probable outcome?
I'm gonna walk out here with $1.
Please.
Yay!
Oh, yay! You lost it. Okay, so there's 2 in there, okay. So this is
One
that.
there.
Oh my goodness. That was sickening. That was sickening, especially since you picked the right direction to make us nervous.
I mean, I don't know how you think I do this, but there's no magic here. Like, there's no magic here.
Oh.
Okay. Okay, so was that the highest probability option?
Yes.
No, it wasn't.
Ah,
No,
You just calculated that, in fact, that was the lower probability option,
yeah, it was.
and yet it happened.
Mhm.
And does that probabilities matter at all?
no, let's jump.
No, let's jump to that. So in fact, the place that we're headed is thinking about large numbers. So we have done samples and you're thinking to yourself, well, there's 52 cards. That's a lot of numbers, Money. No, we want to think about what happens if I did this experiment 100 times and Isabel never changed the course per bet. Would she be a winner or a loser? Right? How much money would she take away? So when you think about large number statistics, this is what we talk about. When we hear the word sample size, we are saying how many times does this experiment run? And therefore, do you have a good understanding of all of the types of events? Because sometimes you have the most probable event, which is here, which is still not very good. And here you have the probability, which is higher, right? Sorry, it's low. And then you think about all of these different ones, and every once in a while, you could look at the distribution and say, how frequently does one person get 4 aces? And if you do this 1,000 times or 10,000 times, say on a computer, and you show the distribution, you should see a relative importance that this one happens 2 and maybe a 25%, 2.25 times more than this. And then so on and so forth in all the other events, right? But as we feel them out, we tend to view the world through very small number statistics. Have you ever had this sensation where you go to the grocery store, you get in line, which line do you get in? The fastest one or the longest one?
Fastest.
No, you never get the fastest one. You only get in the longest one. You don't know why the fuck everyone else is going faster. And you say, God damn it, why do I get in this line? Because part of your brain has a confirmation bias, which says, well, I'm not gonna remember the times that it was perfectly easy to get in and out of the line. I'm gonna remember the times when I was bothered, right? So our brains are stuck in that same way. So because we don't have access to large number statistics, when we think about probability, you will be misled very easily. And I'm here to put a big red flag on the top of your work, right? Which tells you, as we enter into this world of probability and statistics, be aware that even if something seems unlikely to happen, it doesn't mean it's impossible to happen until it reaches a certain threshold, right? Okay. What is the probability if I shuffle these cards that they will become perfectly suited?
Super.
1 over.
1 over
52
5.
factorial.
1 over 2 factorial.
2 factorial.
Oh.
I feel like, yeah, it's like. it has to be
1
lower.
over 52 factorial.
Yeah.
Is that possible to do?
It's
It is
theoretical.
possible to do?
But
Is it
not-
likely?
not.
Good. So this is the distinction we're gonna make, okay? Okay. Thanks, folks.